Alright, so we're going to be going over how to multiply scientific notations together, and then later in this video how to divide them. But first thing is, what is scientific notation? Scientific notation is written like 3 times, I have changed my color here, sorry, 3 times 10 to the third. And what it's used for is it's used to represent larger numbers. So this would be the same number as 3,000. So 3 times 10 to the third is the same thing as 3,000. So it's just a great way to represent large numbers easier. And a lot of times when you're using your graphing calculator, you'll see that it'll put it in scientific notation just so it can fit it into the calculator screen. Alright, scientific notation, most important thing is that this number must be between 1 and, basically between 1 and 10, but not 10, so like it could be 9.9. Alright, and it should be times and then a base of 10 to some kind of exponent. So here's an example of what it looks like when you're multiplying scientific notations together. Your first step is to rearrange the order so that you multiply the tens, the base 10s together, and then you multiply the numbers together. So what I did is I took this, okay, and I wrote this 2.3 times the 4 out front, so 2.3 times 4, and then I took the 10 to the 5th and the 10 to the 7th and multiplied them together second. Alright, then after you move them around, you're going to combine your terms together. So you're just going to take this 2.3 times 4 and multiply them together. That is 9.2. And you're going to take the 10 to the 5th times 10 to the 7th. This is a base to a base rule, so we would add the exponents. So we would take this 5 plus 7 and we make it a base of 12, and that would be your final answer. So to multiply these two scientific notations together, this is what it's going to look like, and that's precisely how you're going to do it. Now, if you can skip this step, right, if you can just go from here and multiply your numbers together and write 9.2, multiply your tens together and write 10 to the 12th, then you can do that without actually having to write down or to work this step out. Okay, this is just there to help you understand how this works. All right, 9.9 as you see right here, right? This number out front's got to be between 1 and 9.9. So it can't be 2 digits. It's basically got to be 1 digit, and then you can have 1 point or 1 number after your decimal. And then dividing scientific notation is a little different. So you typically won't see this like this example like this. You'll see them actually written on top of each other like this. Okay, and that might make it easier to see how we're going to do this. So we're going to approach this just like we would when we were simplifying exponents, okay? First thing is to divide the numbers. So what is 3 divided by 2? Well, or not 3 divided by 2, sorry. 6 divided by 2, because these are our numbers here. 6 divided by 2 is 3, or 3 over 1. And then we would simplify the base 10. So we have 10 to the 9th on the top, we have 10 to the 5th on the bottom. They're the same base. This is called the quotient rule, so we would subtract the exponents. We would take 9 minus 5, that's 4, so we would have a 10 to the 4th up top. Or if you use the method of saying where are there more 10s at, that would definitely be on the top, and how many extra are there on the top? There's 4 extra on the top. So your final answer would actually just be 3 times 10 to the 4th power. Okay, I think that's pretty self-explanatory. If you're good at using the quotient rule, then you should be just fine. Alright, so here's an example with some negative exponents in it. First thing we're going to do here is we are going to multiply our numbers together. 4 times 3.2 is 12.8. We are going to multiply our tens together. Again, this is a base to a base, so we would add those. So we would take a negative 3 here, and we would add a negative 4. When we add this together, we get negative 7. Okay, yes, and it is okay to have a negative power for scientific notation. When you have a negative power, that just means really small number. Okay, but there is one problem with this, and the problem is that my answer is actually not in scientific notation currently. It is not in scientific notation because this number out here again has to be between. So what I need to do is I need to change that. And what I'm going to do is I'm going to take this decimal point and I'm just going to move it 1 space to the left. Okay, so that's going to get me the number 1.28, which I'm then going to round, right? I want to round this just at 1.3. or my problem is I can't just change the number because that changes the answer, right? I just went from 12.8 to 1.28. That changes my answer by a lot. So what I'm going to do is I'm going to adjust this power here to account for that difference, right? And how I'm going to decide which direction to move that is what I'm going to think about is I'm going to think about, well, what did I do to this number? Did I make it larger or did I make it smaller? Well, I went from 12.8 down to 1.8. So I made this number much smaller. So in order to equal that back out, I need to make this number bigger. And to do that, I need to just take this exponent and I need to just add 1 to it. So I'm going to take -7, I'm going to add 1, and that's actually going to give me a -6. So my final answer here will be 1.3 times 10 to the -6. Okay, I think we're going to need to go over a couple more examples here. So let me add a quick page here. Why is this not adding this page? Okay, and let's start writing. All right, let's write an example here. How about 3.4 times 10 to the 10 times, how about 6 times 10 to the 3. All right, so we're going to multiply these together. So again, you're going to take 3.4 times 6. That should be 18, that should be 20.4. And then you're going to take your 10 to the 10 times 10 to the 3. Again, this is the base to a base rule, so we would add the exponent. So 10 plus 3 is 13. Okay, and then my last step is, well, this isn't in scientific notation because my number out front here is not a single digit. It needs to be between 1 and 9.9, so I'm going to move this decimal, place 1 point to the left. So I'm going to make this 2.04. And then again, because I changed this number, since I moved this decimal point and made this number smaller, I'm going to have to readjust this number to keep the number the same. Okay? And how I'm going to do that is this number, again, it was large, I made it smaller. So I made it smaller, so I need to do the opposite to keep this thing balanced. So I need to make this number bigger. And I'm just going to add 1 to the exponent. All right? So basically, from here to here, I changed this thing by a factor of 10. So basically, I made that 10 times as much. But to go from here, I made it 1/10 as much, or basically I divided it by 10. And as you can see, I multiplied by 10 for this number, and then I multiplied by 1/10 for this number. That's really multiplying by 1, right? If I take something and multiply by 1/10 and then multiply by 10, I'm multiplying by 1, which isn't actually changing the number. So that's why you need to think about it as, what did I do? Did I make this number smaller or bigger? And then just make sure you do the opposite over here. All right? And let's do one more example. Let's do a quotient rule. Let's do a 4.1. Oh, wait, I'm not going to be able to divide this. 4.4 times 10 to the 7 over 8.8 times 10 to the -2. That's going to be a tough one. First thing to do is divide the numbers. Take 4.4 divided by 8.8. You should get 1/2, or 0.5. All right, because we're writing it in scientific notation, we're going to write it as a decimal. Again, that's 0.5. All right, and then we're going to take our bases. So again, the 0.5 came from taking 4.4 and dividing by 8.8 and just simplifying this fraction and writing it as a decimal. Now I'm going to simplify these. So what I need to do is simplify these as the quotient rule. I would take 7 minus -2, and that's going to give me 9. So this is going to be a 10 to the 9th. Or again, you could think of this as, where do I have more 10s? I have more 10s on the top because I have 7 up here and I have -2 down here. And how many extra are up here? And that would mean that I have 9 extra because 7 is 9 more than -2. All right, so I get to here. And now what I have is I have something that is not between 1 and 9.9. It's actually too small this time. So what I need to do is I need to move that decimal point to make it a number between 1 and 9.9. So I move the decimal point to the right, So this is now 5.0, or just, we can just call it 5. I'll just erase that 0.0, just call it 5. And again, we have to adjust for that with the base. So what I did is I made this number smaller. Actually, I did not make that number smaller, sorry. I went from 0.5 and I made it 5, so I actually made it much larger. So that means that this needs to be smaller. And again, you're only going to adjust this thing by 1. Alright, so we need to make it smaller, so we're going to go down 1 to 8. Alright, and what I just said you're always going to adjust it by 1. Well, that's not necessarily true. And I'll show you quick. Because if I have something like 116.2 times 10 to the 12. Okay, when I move this decimal point, I'm actually going to have to move it more than once. I'm going to have to move it twice. So I'm going to have to move it once to here, and then another time to get to here, to make that a 1.162. Okay, and what happened, I made this, went from 116 to 1.16, so that means I made this number much smaller. So that means the base of 10 needs to be made larger. And this time it doesn't need to be made larger by 1, it needs to be made larger by however many times I move this one. Well, I moved this one twice, so I need to make this one larger, and I need to move it twice, which means I need to move it up 2 from 12, and I need to make it 14. Alright? That's kind of an advanced example there at the end, but that's how you use your exponent rules to multiply scientific notation together. Okay, so, wow, I added 13 pages. I'm insane. So let's go back to this page.